how the digital world around us works? Well, the answer lies in the magic of coding. You see, coding is like the secret language that powers our digital universe. It's the building block of all things digital, from the websites we browse, the video games we play, to the mobile apps we use daily. Imagine a world without coding. Without it, we wouldn't have the convenience of online shopping or the thrill of multiplayer online games. Even the phone in your pocket wouldn't be as smart without the lines of code that make it tick. In essence, coding is the invisible thread that weaves together our digital experiences. But coding isn't just about creating digital products, it's also about problem solving. When faced with a challenge, coders use their skills to find innovative solutions. They're like digital detectives, sifting through lines of code to find and fix issues, making our digital world run more smoothly. And then, there's the power of creation. With coding, anyone can bring an idea to life. Want to build a website for your business? Code it. Dream of creating a fun mobile game? Code it. The possibilities are endless, limited only by your imagination. Learning to code can open up a world of opportunities. It's a sought-after skill in many industries, from tech and finance to healthcare and entertainment. Knowing how to code can give you a competitive edge in the job market. Plus, it empowers you to create your own digital solutions, whether it's a custom app or a website. So, why is coding important? It's the force that drives our digital world. It's the tool that turns ideas into reality. It's the skill that can open doors to new opportunities. Without coding, the digital world as we know it would not exist. So, what exactly is coding? Well, let's dive right in and unravel this mystery. At its core, coding is the process of using a programming language to give computers and other machines instructions on how to perform tasks. It's like a recipe, where you lay out the ingredients and steps and the computer whips up the result. Now, just as there are countless recipes in the world, there are also numerous programming languages. Each has its own unique strengths, applications, and quirks. Let's take a peek at a few of the big players. Python is often the go-to for beginners. It's straightforward, versatile, and its syntax reads almost like English. Python is commonly used in data analysis, machine learning, and web development. Next, we have Java. No, not the coffee, though it might come in handy during late-night coding sessions. Java is object-oriented, meaning it groups related tasks into objects. It's widely used in enterprise-scale applications and Android app development. Then, there's JavaScript. Despite the name, it's unrelated to Java. JavaScript is primarily used to make interactive elements on web pages. If you've ever played an online game or filled out a web form, you've likely interacted with JavaScript. Each of these languages, and indeed all programming languages, have their own syntax, the grammar and punctuation rules of the language. Imagine trying to read a book without any punctuation or capital letters. It would be pretty confusing, right? Syntax helps us avoid such chaos in our code. But here's the interesting part. While the syntax varies from language to language, the underlying logic of programming is often similar. Concepts like loops, conditionals, and variables are universal. Once you've mastered the logic in one language, picking up another becomes much easier. So think of coding as learning a new language, one that allows you to communicate with machines. It's not just about memorizing commands and syntax. It's about understanding the logic, the flow, and the problem solving that drives it. Coding is a skill, a craft, and for some, it's an art. So, are you ready to start your coding journey? Now, how does one go about writing code? Think of coding as a way to give instructions to your computer, similar to how you might direct a friend on how to reach your house. You wouldn't just say, "Come over," right? Instead, you'd provide a series of steps like, turn right at the end of your street, go straight until you see a big tree, and so on. In the world of coding, these step-by-step instructions are known as algorithms. Imagine you have a list of numbers, and you want to find the largest number. You could just look at each number and keep track of the largest one you've seen so far. That's an algorithm. You start with the first number, and then move through the list one by one, constantly comparing and updating your largest number so far. Simple, isn't it? But your computer doesn't understand human language, so you need to translate these instructions or algorithms into a language that a computer can understand. This is where coding languages like Python, JavaScript, or C++ come into play. Each language has its own syntax and rules, much like different human languages. Your algorithm, when translated into a coding language, forms the code that your computer can execute. Let's translate our algorithm to find the largest number into Python. It might look something like this. Here we're defining a function called find_largest that takes a list of numbers. We start by assuming the first number is the largest. Then, we go through each number in the list. If we find a number that's larger than our current largest, we update largest to that number. Finally, we return the largest number. In essence, coding is like a puzzle. You have a problem to solve and you need to figure out the steps to solve it. Then, you translate those steps into a language your computer can understand. It's a process that requires logical thinking and problem-solving skills. Coding is all about problem-solving and logical thinking. What happens when your code doesn't work as expected? Well, that's where an essential part of the coding process comes in: debugging. Think of debugging as a detective's work, where you're on a quest to find and fix the bugs or errors in your code. Bugs are essentially hiccups in your code that cause it to behave differently than you intended. They could be anything from a simple typo to a complex logic error. Debugging is the process of identifying and correcting these bugs. It's like a game of hide and seek, where the bugs are hiding and it's your job as the coder to seek them out. But how do you find these elusive bugs? Well, there are several techniques you can employ. First, you can use a debugger, a tool that lets you step through your code line by line, examining the variables and watching the flow of execution. This can help you spot where things are going off track. Another technique is to add print statements to your code. These allow you to see the values of variables at different points in your code, which can be incredibly useful in tracking down bugs. It's also important to understand that debugging is more than just a process. It's a mindset. It requires patience and perseverance. It can be frustrating when your code doesn't work as expected, but remember, every bug you find and fix is a step towards a better, more robust program. Remember, even the most experienced coders encounter bugs. In fact, they see them as opportunities to learn and improve. So don't be disheartened if you find bugs in your code. Embrace them, learn from them, and use them to become a better coder. Debugging isn't just about fixing code, it's also about understanding your code better and learning how to write better code in the future. It's an opportunity to learn and grow as a coder. So next time you encounter a bug, don't just see it as a problem to be fixed. See it as an opportunity to improve. Debugging is an integral part of coding. It's where a good coder becomes a great one. So why should you learn to code? It's a question you may find yourself pondering as we wrap up this journey through the world of coding. Let's take a moment to recap the key points we've touched upon, and perhaps the answer will become clear. Remember when we discussed the significance of coding? It's not just about building websites or creating apps. It's about understanding the digital world we live in. It's about gaining the ability to manipulate and control the very fabric of our modern lives. When you learn to code, you're not just learning a technical skill, you're learning a new way to think and solve problems. And let's not forget the basics of coding we've covered. Like any other language, coding has its grammar and vocabulary. Understanding these elements, from variables to functions, loops to conditionals, is essential for anyone looking to delve into the world of programming. We've also broken down a coding process. Remember how we dissected a problem, planned a solution, translated that plan into code, and then tested and refined our program? That's the heart of coding. It's a cycle of problem solving that demands creativity, logic, and tenacity. Then there's the art of debugging and troubleshooting. Coding isn't always smooth sailing, there will be errors and challenges along the way. But as we've seen, these are opportunities for learning and growth. They're chances to refine your code and improve your skills. So, why should you learn to code? Because it sharpens your problem-solving skills, expands your career opportunities, and equips you with the ability to create and control digital products. It's a language that opens up a world of possibilities, whether you're looking to build a website, develop an app, automate a task, or simply understand the technology that powers our lives. There are plenty of resources out there for beginners eager to start their coding journey. Online tutorials, coding boot camps, free coding platforms, the world is your oyster. Coding is not just a skill, it's a language of the future. Start your coding journey today and unlock a world of possibilities.